get started. Welcome. Glad you can join us this morning. So I'm Peter Johnson. So I'm one of the WPILib volunteer developers. People ask me if I'm the lead. I guess I am. Out of informal consensus, we're more like an autonomous collective than a strong leadership sort of organization, hierarchical organization. I'll get started just to get things along. 45 minutes sounds like a lot of time, but it's really not. I hopefully don't have too many charts here, and roughly organized in the order of it. I'll get started with WPILib mission. And by the way, just for a logistics thing, these charts will be posted to Sheep Delphi probably right after championships. May make a couple of edits to them after that. Based on feedback from what's going on at championships. Part of the reason I come here every year is to meet with people and get feedback and talk to FRC and talk to other vendors. So in general, WPILib's mission is to really enable FRC teams to focus on writing game-specific code. So rather than worrying about how do I create electronics and drive a PWM signal, we want you to think about, or how do I write a PID control loop? It's, what can I do with that PID control loop? How can I do something at a higher level yet? How do I do vision? How do I do some of the higher level autonomy that you're seeing robots do this year? So that's one part of the mission. Another part of the mission is to, in general, make new technology available to teams, and so in that way, raise the floor and don't lower the ceiling. Essentially enabling teams with limited programming knowledge or mentor experience to be more successful in the competition. And if you have more intermediate programming knowledge and some mentor support, you can use powerful tools to improve your robot performance. And if you have advanced knowledge, you can use the full power of the system. We aren't limiting you in any way from going above and beyond what we provide. Another key piece is we do need to support the kit of parts system hardware, things like controllers and sensors. Clearly vendor libraries is kind of above and beyond what we support in the standard set of stuff, but in general, what's in the kit of parts we want to have included in the library. We also work to provide parity across all of the officially supported languages. I'll talk about the official languages in a couple minutes. Most of you probably know what those are. But essentially, we want to enable teams to pick the language of your choice without worrying about, I can't do X in this language, right? So essentially, the library and all the tools need to be robust, reliable, maintainable, and understandable, debuggable. All those good words for a piece of software. That's what our library needs to be as well, in the hands of high school students, sometimes with limited mentor support. So it's a challenge. So a little bit about where we fit in with the overall control system, kind of help set the stage here. The WPILib team, we started, it was started at WPI, which is therefore the name, WPI Worcester Polytechnic. Largely now, the team is mostly made up of volunteers. And we do the C++, Java, Python libraries, network tables, camera server, all the things that you typically interface to outside of the hardware and the driver station pieces. Like a lot of the software libraries for C++, Java, and Python we do. Now, National Instruments does RoboRio image, libraries, how the RoboRio talks to the driver station at the low level. LabVIEW, of course, is a National Instruments product. And driver station dashboards, and some of the lower level stuff. Vendors provide vendor libraries, so your CTRE, your Rev, some of those other software libraries or add-ons. We don't maintain that as part of the WPILib team. We work with them to make sure it all plays nicely together, but they're responsible for the documentation support and the software there. And then FRC handles the FMS, the radio, the field network, all of those aspects. So kind of, hopefully that helps you figure out where we fit into this overall picture here. So a little bit of history. WPILib has been around for a long time. So in pre-2009, so this is before the Compact Trio. This is back in, for those who were around that long, IFI controller. There was a C. It was all programmed just in C. And so it was one of several options there. Really started to take off in 2009 with the Compact Rio. The C++ version of WPILib became an official language. And Java was added in 2010. That was Java 6 at the time. So very limited capabilities. And the same year, actually, the Robot Pi project started, which ultimately was adopted this year into the main part of WPILib. 2015 brought around the Robo Rio. We moved to GitHub. The volunteer contributions really started to take off. So you can kind of see after that point, a lot of the tools that you as teams are familiar with today were really getting introduced in the following years. And in the last couple of years, continuing to make great progress, particularly in integrating tools that have been developed by the community, such as Advantage Scope, Python, as well as adding new features to teams. So in terms of the official languages today, there's 4 officially supported languages. So there's C++, Java, Python, new for 2024, and LabVIEW. So there's roughly equivalent feature sets. As I said, that's a goal of our program. We found that the general driver of language selection is network effects. And you're seeing, in terms of language usage this year, or this is of course 2023 data, that 86% of FRC teams use Java. Well, that's grown every single year for the last 10, 15 years. Every single year, the percentage of teams using Java has gone up. And there's a number of reasons for that. Again, I think it's primarily due to network effects. Teams that use it, you have supported events, you have an online support base. So there's custom libraries that teams develop in Java, so that then get community network effects. So, of course, it's still always a team choice, right? Teams should pick what works, and my advice to teams is always pick what your mentors know. Like if you have a mentor that knows Python or a mentor that knows C++, they can help you along the way. They're your first line of support. So, you don't have to use Java. It's all about picking what works best for you as a team. So framework-wise, currently there's 2 frameworks. There's timed robot and command-based. We call it command-based V2. There was an older command-based. What's very interesting here is that in last year, 62% of all FRC teams used command-based Java. So it's definitely the dominant language and framework. That being said, you can be very successful programming your robot in other languages and frameworks. I'm just kind of communicating what kind of the dominant facets are, and clearly, people sometimes ask me online or in other forums like, oh, if you add this language, will Java go away? No, Java's not going away. We aren't going to say, oh, 86% of teams, you need to switch languages. No, that's not going to happen. So that hopefully helps set guidance for the future there. So from an overall direction going forward, so talking a little bit about the past. So what's going forward? So we do definitely plan on continuing our open source community volunteer-driven development. Another major focus, if you haven't heard about it yet, there's first released a request for proposal for a 2027 robot controller that will replace the Robo Rio. Don't know, it's a competition, so we don't know who's going to be building that controller yet. The other thing that in joint with that announcement is that robot controller is going to be for both FTC and FRC. So, which I think is great news for teams. That's going to really enable teams to more easily move students between those programs. Whether it be a team chooses to switch from FTC to FRC or vice versa, or use it as a learning platform with middle school students moving into it. But it does really open up the aperture for what we as WPILib need to be looking at for future development. And looking forward very much to working with the FTC development team that has been involved with doing the FTC control system to date, making sure that we meet team needs together to meet team needs in the FTC environment. Clearly, some of the other broader goals haven't really changed, right? It's helping teams discover our capabilities and be more successful with them. And, embracing those community tools, finding hey, if the community develops something awesome, like, let's make that available to all the teams. Let's make that a standard. Like, let's, essentially turn de facto standards into actual standards, right? If everyone's using this piece of software, let's adopt it and make it officially supported. The other thing is really prioritizing quality of life improvements over new features. This is going to be particularly the case for the next couple of years for the RoboRio platform. We're going to be in parallel trying to develop stuff for the new robot controller. So we're going to need to work through the next couple of years with the current robot controller and its capabilities, and then maybe limit how much we do there as we focus on 2027. But certainly, we know that stability is a key thing for teams. Matches, are very, very important for everyone. And having, the worst things I hear about, as a volunteer are, when a team fails in a match due to a bug, right? That's not what we want to have happen. So stability is really important to us. And from a team experience perspective, you spend a lot of your time as software developers debugging things. So the more tools we can put into your hands on figuring out where the problem is, the better off you're going to be. So that's why it's been very rapid adaptation over the last couple of years of data logging, Advantage Scope. Some of those tools are key to enabling you to quickly debug your software, and that's what we want to provide teams and continue down that path. From a documentation side, a lot of the documentation today, FRC docs, started, 4 years ago, I'd say?
In its current form.
In its current form, started 4 years ago. Really grown. There's a huge amount of documentation there. Huge amounts of documentation on docs.wpilib.org site. Now, that documentation is pretty high quality documentation compared to a lot of documentation I see in the industry. However, it tends to be a lot more about here's how to use the software that's there. Like, this class does this functionality. It doesn't do a good job of saying this set of tools or these classes solve this problem, right? This is why it's useful, why you want to use it. So the why is kind of missing. There's a lot of good what description, but you'd like to get more of the why. About this is why you wanted to use data logging. Yes, we also have the documentation on how you actually do it, but why you want to use it is something that we'd love to add more of. As you've seen over the last few years, and robots out in the field today, right, the amount of robot autonomy has dramatically increased in the last 5 years. That's great. We love to see it. We want to continue to provide tools to enhance that, right? Enhance the team experience. We know that there's a number of, WPILib distributes a pathfinding tool called Pathweaver. Most teams aren't using it. It doesn't support Swerve, right? So a lot of teams are using Pathplanner or Oreo or some of these community tools. We want to, that's stuff we're looking at, okay, how can we, work with the community, adopt those tools, make them more widely available, more documented, so, again, raise up the floor, help teams be successful. And, in terms of best practices, that's another area where, tools and documentation are key to that, for figuring out how to write a robot in an effective way that's going to be easily debuggable, figure out what's wrong, be successful on the field. I'll have a lot more detailed charts here. I kind of want to give an overall guide to how I was going to present the information. So I got some things marked as community. So that denotes community-provided tools and software that we don't currently bundle, support, or document. Right, stuff that the community has provided. There's clearly a lot of stuff the community does. We capture stuff in roadmaps, and then the community goes and does it. That's exactly what we want to see happen. We don't have to develop it all. We love to see the community develop things, and then that's the easiest way to grow us as a provider of software to teams. Is if the community doesn't, we only have so much bandwidth amongst our small group, volunteer group. So integrated again denotes stuff that we've integrated into WPILib now, and that we bundle and document. So just for a bit of history here, we presented a roadmap in 2022. So there was also a long-term roadmap, but we're doing a new one 2 years later. Well, long-term is relative in FRC, as you know. We move very quickly, so it makes sense, particularly with the release of the MRC to be talking about a refreshed roadmap for 2024 and beyond. So we looked back at what we talked about in 2022 and said, hey, we actually checked off some of these items. We had success, and teams are having success with those items. Really, I called out some specific items where we'd love to have more help from the community. Particularly one of the challenges we have is it's easy to build new software. It's not as fun to maintain it. A lot of what we do is maintenance, we would love to have more maintainers. So volunteers who step up and are willing to review pull requests, review bugs, fix bugs. That's a huge part of what we do, and in general we would love more help. Even in small things. I mean, even if you're a student on a team and you just find an issue, report it. We don't know about it unless you tell us about it. And if it's a small fix, just PR it. We're on GitHub. It's easy to PR things. We're happy to have help. So I've called out some more major projects here, but essentially WPILib exists in the form it does today due to contributions, right? It's a community project. None of us are paid. We're all volunteers. And so we want to thank the community for all the work you've done to date, right, to help us. And so looking forward to future contributions as well. I'll just jump through some different areas. How these charts are structured is like, for documentation, let's look at it from a roadmap perspective. 2 years ago, we were open source, read the docs. We have translations to multiple languages, lots of solutions-based documentation. Again, in the future, we're going to need to add FTC docs, right? FTC is, we're going to need to support FTC. FTC is going to need documentation. There's going to be updates for the mobile robot component. I'll talk about it in a little bit, but one of the things that is part of the RFP is on robot development. So what does that look like? We're going to need documentation. We're going to not just develop it, but talk about how do you install stuff, right? How does that work? What does deployment mean if you're running it on robot? Problem-focused documentation, I already talked about a little bit. Clearly one of these things where the vendor separation here is both good for teams and it's a challenge, right? So the vendors, having the vendors' libraries be separate has been super helpful for vendors to iterate and do releases outside of our release cycle. Otherwise, we'd be doing a new WPILib release every week probably, because a vendor updates something, then we have to do a release. So breaking that dependency chain is good, but it does mean that there's vendor documentation and there's WPILib docs, and the two don't always connect very well. We'd like to see more connections between those two. It helps teams find the information that you need. The overall docs is quite large, and from an organizational perspective, this is a huge challenge. There's so many docs that it's actually hard to find stuff. I personally tend to use the search engine feature more than trying to drill down in the menu. We'd like the menu to be more useful, so this is clearly something that we'd like to work on as well. Kind of maybe features, it's kind of cool to have a click to run sort of thing, like, there's an example link in a doc and you can just click it and it pops up VS Code with the example project. That'd be pretty cool. More advanced project, we might get there. It's not a huge priority for us, but if somebody wants to work on something like that, we can certainly take it, right? So robot languages, I already mentioned before that we're currently using. Most of this is kind of version changes. So, a couple of years ago we were on Java 11, now we're on Java 17. Certainly we plan for both C++ and Java to continue to track language evolution there. Java does LTS releases every couple of years, so we'll continue migrating on that. Same thing with C++ and Python as well. In terms of future languages, people love to talk about Rust or C# or JavaScript, or there's lots of different things out there. Effectively, Robot Pi became an officially supported language after 10 years as a community language. That's probably an overly long period of time given the team uptake of it. We probably could move faster on that, but I think that's probably the path for future languages as well, is if somebody creates C# and builds the library system around it, and there's 100 teams using it, like, hey, that's something we should probably be looking at adopting for future official use. We know that C++, for those C++ teams out there, compilation times is a real issue. There's a couple of reasons for that, but certainly one of the things we'd love to do is C++ module support. Even in industry, it's not there yet. It's like, oh, if you're running a beta version of, or pre-release version of GCC, like you can use modules, but it'll be there in a few years. So by 2027, it'll be there, so we can do that transition. That should help compile times. I mentioned earlier that telemetry and data logging analysis is really big. For us, it's a major focus area. Network tables has been there. There was pub sub development with Network Tables 4 that's been available to teams for a couple of years. Annotation-based telemetry is something that's really popped up. In particular, this year, it's been available in the past, but Monolog is the main one that's available this year. We'd like to get that into the hands of teams as an officially supported thing. It definitely does ease some of the burden of how do you get extra telemetry out with lots of verbose code. We've already officially adopted VantageScope as a unified offline data analysis tool. Certainly looking forward to that seeing continued development. There's probably the future here is more minor improvements. We've gotten a lot of what we want out of this, and then it's improving the tools that we already have. Annotation-based telemetry trying to be the primary. Driver dashboards. So currently there's most teams, the official ones at least, are Smart Dashboard and Shuffleboard. Were available in 2022. There's kind of a Venn diagram of feature sets. Not everyone supports everything. There's a couple of community ones. The Elastic is a fairly popular one that's been come out from the last couple of years. That's a WebTech Shuffleboard equivalent. There's also WebTech dashboard components that you can build your own HTML-based dashboard with FRC web components. Really, we probably are going to see, I'd like to move towards integration of those things, making those more available to teams, as tools. But maintenance is a challenge, right? We need to make sure that there's someone to maintain those tools over the long term. We probably will retire Smart Dashboard in the next couple of years. The main issue with it is we can't actually compile it for all the platforms anymore. The code is basically maintenance mode hasn't been changed for years, and so we can't actually make it available for Mac ARM processors, for example. So that's going to start limiting us, and hopefully with some of these newer tools, teams can feel comfortable moving off of that to some of these other alternatives. I didn't put it on the chart, but in general for dashboards, I think there's kind of going to be a bifurcation of dashboards emerging, where there's going to be driver-focused dashboards, like ones you put on your driver station for your team to use when driving the robot around in a match. And then there's going to be programming-focused dashboards, which are much more about diving into data-oriented, not less big red button type of dashboards, but more like, oh, I want to graph these 10 things. Like VantageScope and Glass both fall into that category, but they don't make good driver dashboards, right? So we need a driver dashboard that is kind of much more that big picture interface. Let's see, team code structure. Again, command-based robots are is hugely used right now amongst teams. There's a number of community sort of frameworks emerging. AdvantageKit, I know, is used by a number of teams. So certainly going to expect to continue to see command-based being a dominant framework. Like to integrate more of what's been going on with Path Planner or other autonomous tools to better structure code in autonomous mode. The one giant command sequence for your entire auto is a bit unwieldy. So there's better ways to do it. We need to give examples of better ways to do it, and provide the tools for better ways to do it. So that's what this trigger-based autonomous structure really is the idea that instead of one giant command structure for the entire auto, you set up triggers to happen at different points in time. Use the trigger framework to have events happen at points during that auto period. So know that a number of teams run into challenges with one big command group with background commands not running, default commands like, oh, I want to keep the arm in this position even though I use the arm only at this point in the in the auto period. So fixing those sorts of things is certainly areas where we see pain points for teams, and trying to fix those, provide good tools for teams. Another area of research on code structure is code routines. A few different languages support them. It's kind of an interesting way to think about code structure, particularly auto code structure, where you can kind of write code in a more sequential way, but then have it run in a periodic way behind the scenes. So it's just very experimental work being done on that right now. The language support generally isn't quite there yet, and it requires different mental models. So it's probably a ways away from really getting it out in the hands of teams, but certainly stuff we're looking at. So cameras, image processing, co-processors. So the camera sorter library is available. WPILib is available. We've added support for able tags, based on what first is on the field. From a community aspect, there's Storytime Vision. Of course, there's vendor solutions as well, like Limelight. In the future, kind of the path here is, one of the big pain points for teams, although hopefully it's gotten a little bit better with the new radio, is video streaming has been painful. It's been a pain point. The current approach we use is a TCP-based. Basically is a MJPEG or HTTP. So not super bandwidth efficient, not super low latency, because as soon as you get network congestion, it backs up and the frames get delayed, and you end up with these like 300 millisecond delays on your camera stream, which isn't great. So we'd love to go to something UDP based. It's been on kind of my backlog list for a few years now. The other kind of interesting thing is going to more efficient codecs like H.264. The challenge here is that there's licensing issues as well as platform capabilities. It may be interesting. I was surprised to learn that basically almost all embedded coprocessors like Pi 4s, Pi 5s, do not have hardware H.264 encoders. It's all software. So they have decoders, but they don't have encoders. So it's kind of an interesting place where, it's more bandwidth efficient, but you're paying a cost in processing. And certainly the mobile radio doesn't have the horsepower to do it. So something active area of research, I would say. Just JPEG over a UDP-based stream would probably be fast enough for our purposes, particularly with the new radios. Certainly other quality of life things like web-based precision camera configuration, so you can just go to a web page, set some stuff, rather than having to do all through code. Improving PyCam support on coprocessors. Having standalone application for performing camera stream viewing. All these sorts of things are quality of life improvements. Above and beyond kind of the core of how we get the video from the robot to the fire station. So vendor integration. I mentioned earlier that we've got vendor depths all set up independently. We'd love to get to a point where we have a centralized catalog of vendor depths in the IDE, so you can just go, install a vendor dep, and it has a menu that lists the options. That just reduces the installation pain point of which website do I have to go to? What's even available? What vendors have libraries? What don't? Similarly, and this is kind of because a really important thing for us is the offline installation capability, is having a integrated downloader installer. So essentially, when you're going through the installation process or doing a first pass of I just want to check box all these things that I want to download all these vendor depths in addition to the WPILib stuff. Say it's similar sort of concept, but more on the first time installation side. Certainly there's a number of vendors who have open source libraries, and it's a lot of work to maintain a vendor dep. So, we certainly want to be talking with vendors about, hey, you don't have to create a separate vendor dep thing. You can contribute it as long as, it will just make it clear that who's responsible for maintenance of this is not the WPILib team, but it's all bundled, and we handle the distribution side. So it's more like the Linux driver model. So Linux, the all sorts of vendors make all sorts of products that need Linux drivers, and it just gets included in the kernel. The only requirement is open source. I think one that may get increased interest in the next few years, particularly as we start adding FTC stuff in, is some sort of idea of a vendor-agnostic smart motor controller function. Where there's at least basic functionality out of the box for your CTRE motor controllers, your rev motor controllers to read the sensor values, do closed loop PID on the motor. Those sorts of things where it would help in multiple ways. One of the issues we have in the documentation right now and some of the stuff we're doing with advanced controls is that the only examples we can really effectively put in our docs are ones where it's PWM motor controllers. And that's not particularly useful for teams because we know that the vast majority of teams are using CAN-based motor controllers. Like, why are we doing examples of PWM? It's because we don't have the library support to do anything with CAN. So we have no way to build and test and make sure those examples work. So that's an area where we've been talking about for a few years. We may see some level of traction in the next couple of years of figuring out a way to do this. So training and education. 2022, we had actually just introduced the ROMI a couple of years before. Today we have the XRP platform. For those who aren't familiar with the XRP, you can just go on SparkFun, Google XRP. It's a PyPico-based platform. You can use it with WPILib. So WPILib runs a simulation, controls the robot remotely. The great thing about this educational tool is that SparkFun site, the list price is $115, but for teams it's $65. So you can have a robot that has motors, sensors, gyro, that you can take home with you. It's inexpensive enough that teams can take it home, program it home, and do basic driving techniques, basic sensor, basic mechanism control, and learn the programming skills with a physical item, which is always, for those of you who are mentors, that's some of the biggest challenge, right, of getting students going is seeing something move is a huge light bulb, right? It's like, hey, I wrote this line of code and something moved physically. And that's really an inspirational thing, gets students excited about programming, and so that's a very, from a learning and training and education perspective, we continue to see those sorts of platforms as being huge, and there's a lot of momentum. I'm happy to say there's a lot of momentum behind XRP. So that I hope to see that continue to grow in the future. Certainly some other work we're doing from an entry-level perspective is Robot Builder, kind of a V2.0 of that, in terms of doing something maybe interactively in VS Code to make it easier to write commands, something that's web-based. So rather than from scratch project, I want to describe out my subsystems in a little bit general detail and writes the code for me. The other thing is a Blockly style builder, whether that be Blockly itself or something similar to it. FTC has this sort of language. We're going to need to have something like it for FTC. I think it's also going to help, entry-level FRC programmers, right? It's like it separates the syntax from the function, right? So you don't have to. I can figure out how to write the functions, but need to put semicolons after everything throws me off when I'm just getting started learning. And that's a way to separate those two things and help students learn. So there's other things on the radar that we've kind of brainstormed out. Things like tutorial-based VS Code plugin where it's all interactive and you just click this and let's add a drivetrain and it's all interactive inside VS Code. That'd be pretty cool. Kind of like a Jupyter notebook for learning. ID and build system. Today, as well as 2022, VS Code in Gradle Rio, FYI, was a community-based project to start with, and then we adopted it. So this is another example of adopting community development. I mentioned that one big area for future focus is on robot development with the web-based environment. Currently the leading candidate in my mind there is VS Code is a web-based thing. There's VSCode.dev. There are ways to run it on embedded processors. Figuring out that is something that we absolutely need to figure out. It's a requirement for the 2027 MRC to have some sort of on-robot development. That's big for both FTC and FRC. I know there's a lot of schools out there that only have Chromebooks or have very locked down IT laptops, right? So it doesn't work for a driver station as well, but for programming, like if you could use a Chromebook for programming your robot, that opens up a lot of options for teams. So some IDE support for deploying coprocessor programs would be nice. And the other thing is that particularly for C++, using Gradle has been a bit of a pain point for C++ teams, both from a build time perspective and using external libraries is a little bit more of a challenge. So I suspect we're going to, I think the path we're on is going to be use more industry standard tools on a per language basis, like using CMake for C++, using Gradle for Java, using whatever for for whatever languages are out there, is using what tools are industry standard for that language. And to support that, creating a deployment tool that is build system agnostic, so it makes it easier to do all those different languages and build tools is like, okay, there's just a tool that you use to deploy the robot program. The higher levels become easier at that stage. Certainly we know there's a number of teams out there who use IntelliJ. One of our concerns with the reason we're on VS Code is it's a common thing across multiple languages. You can use it for C++, you can use it for Java, you can use it for whatever you want. It's perhaps less great at Java than IntelliJ. But the problem with IntelliJ is it's a commercial platform. So there are educational licenses, there's ways to get that, but it does make it a more challenging environment to distribute to teams versus VS Code, which is free. And then there's other build systems out there as well. So simulation. So certainly, we've had the integrated SimGUI for a couple of years now. AdvantageScope added a 3D environment as well as more visualization tools. We'd like to look at things where we're integrating simulation more into the team development workflow. Doing simulation first, doing more actuator models. Basically making sure that simulation code is in all of our examples, and improving support across the board. Plenty of time. So, drivetrain trajectory planning. In 2022, we basically had Pathweaver. That was all that was out there. We know that Path Planner has become increasingly used in the last couple of years for swerve support, constraints of path command events. Trajectory optimization is another community tool that's gotten a lot of development in the last year. With the great uptake of Swerve, this is clearly a focus area for teams. And we want to get those tools more standardized into the hands of teams. So some level of integration of Path Planner or pieces of Path Planner, working with the community to find the best of breed tools out there and get them integrated is certainly something we want to see happen in the future and get that as part of the standard set of tools we're offering teams. Maybe kind of further future here, things like obstacle avoidance, real-time path planning, those are all more active research areas at this point in time. Really looking to see what emerges from the community as the best approaches for this. This gets more into kind of more detailed controls, some localization, state estimation. We have a lot of the stuff there already. There's some active research work being done with improved pose estimation accuracy. Certainly this is an active area of growth at both the team level as well as our kind of volunteer side as well. So hoping to see continued improvements in these areas as we go forward. And it's exciting to see all of this entering first in general, right? I mean, if you think 5 years ago, like what teams were doing in auto modes, like we didn't have April Tech, we didn't have some of these path planning tools. So it's really exciting to see. Looking forward to the future on this, and all of these controls and algorithms are really key to making that happen. Some more things on controllers, kind of just the big thing here is probably we are on a path to remove some of the controller-specific commands, things like PID command, PID subsystem, Ramsey command. One of the issues with these higher level things is that they tend to have bad levels of abstraction. They're pretty hard to use. So it's much easier to just have a normal command and stick a PID, or a normal subsystem and stick a PID controller into it than have a PID subsystem. So just from simplicity, simplifying the documentation and ease of use, it actually makes sense to remove some things. So that's on our radar going forward. Motion profiles, I think system modeling. System modeling, so SysID has been our main tool for that. It did have a major change this year to go to user-side logging and data capture. I think that's generally worked well for teams. I know there's some angst originally when we announced that change on Chief Delphi, but I think it's generally proved out pretty well that it's a more functional tool for teams. And clearly there's ease of use improvements we still need to do, clarifying docs, doing a better job of step-by-step of like, okay, here's how you really get there. And I think that's it for my last chart. So I'll jump back up, just leave it there. We've got about 10 minutes, I think, or 5 minutes, at the end here for questions. So thanks again for
So you mentioned WPILib support for Raspberry Pi. I did spend like an entire week before competition started this year trying to see if I could get VS Code running with WPILib to like code and use that as the development environment on Pi 5. It didn't work. Is it even possible, or was I wasting all my time?
So it should be possible.
I tried.
Yeah, there's in terms of we're using it, trying to run it on the Pi,
yes.
essentially. It should work. We have a Pi-based installer, but it's, so one of the installers is actually an ARM64 installer. It should run on the Pi. So it's on the release page. Yeah, so it's Linux ARM64 and it should run on the Pi. So yes, it should work. There's probably things that don't work. I wouldn't say it's been widely tested. So, but there is an available installer for that platform. So, yeah.
You mentioned the possibility of a plan for reworking the Robo Builder. It's more of a Robo Builder 2.0.
Yeah.
Will that just be like a rework, or will it include more or newer features?
The plan for it is to, it's a little bit different than the current robot builder. The current robot builder is basically, you have to use it from the get-go, right? You have to use it to basically create your project. The idea with the newer version is to have it more as like, okay, you have a project, I want to add a subsystem here, like, and have new things in it, like the new, like, latest candy motor controllers and control loops and that sort of thing, and help build out the subsystem structure, and then help build out the commands that use it.
Okay.
So that's where so it's a little bit different approach than the current one. Yeah, sure.
Are you planning to convert all of the Java commands and just return static values to units, or will that be more of an option?
It's a good question. So we added the Java units just this last year. We've been gradually adding it to the libraries. It is a major breaking change to change return values. I think we don't know yet is I guess the best answer. We don't want to force units onto Java teams. Even the new units library is designed to be mutable classes, so you don't have garbage collection problems and memory allocation problems with it. So whether that's adding additional functions to that return the unit-based types, something along those lines is probably the first step. We need to think through what the transition process looks like to do that without breaking teams. Yeah.
Here's a sort of language-based question. Is there any minimum, like lower bound or upper bound on adoption rate before you would consider phasing out a language, or do you expect to support all the current free languages in perpetuity?
So it's a good question. So I don't see C++ going away. It is, it's not that much. Actually, the vast majority of the current, kind of core set of contributors to WPILib are C++ developers, it's actually and it's used as a core for wrapping in other languages. So basically, Python is wrapped on top of C++. So C++ really isn't going to go away because it's needed for Python. And the other thing is a lot of the core utilities and other things are all built in C++. So there's a lot of JNI for Java, I think the same thing will be true in other languages as well. And the maintenance burden isn't all that high for the C++ pieces. So I don't really see C++ going away. It's the current least used language, but I don't see anything happening to it. It's also the only one that's not a Python or Java or very much higher level language. So having the option available to teams is important. Python actually we think is on the upswing, not the downswing.
I was going to ask, do you expect Python to eclipse the languages within any time soon?
No.
No. short answer, no. Again, it's again, network effects are huge. The other thing is, Python is great in some ways, not great in others. I mean, one of the areas where Java and other compiled languages excel is you get syntax errors, and you find out if you made a typo in a variable name, like that results in a runtime crash in Python. Like so, there's pros and cons, and we do think we'll see an uptake on it. But given the current dominance of Java, it would be quite a few years, I would suspect, before another language would eclipse Java. So,
Are there any plans for test mode?
yeah, that's a good question. So
What's the question?
Are there any plans for test mode?
Test mode. So test mode is a little bit underutilized right now. Historically, we used it for live window, and the concept of live window was good, particularly at the time. Essentially, what live window was is it auto-populated based on like, oh, I use a PWM port 5 and DIO port 3. Like, oh, I want to see like, do I have the robot wired correctly? So I'm going to, switch over to test mode. It'll pop up a live window view and show like, oh, what happens if you wiggle, a sensor on this value and it bypasses your code, the rest of your code. With how few teams are using I/O resources on the Roborio, it's less useful these days. And so I think what we'd like to do is move test mode in a direction of enabling greater team use of it, for whether that be some sort of integrated automated system test or something along those lines, but really freeing it up for more team use, and we'll see what teams come. Another question?
Are there any plans on the WPILib side to help mitigate issues with Python caused by being an interpreted language?
So, Russell.
So right now, Python has unit tests that run as part of the deploy. They're a little bit unstable at the moment, and I have plans to fix it so that it won't be unstable. That's been pretty effective for at least my personal team's use for the last 10 years. But if you have other ideas on how to address some of those things, it'd be interesting. But I mean, the primary thing with Python is we have to have testing in order to you have to actually run the code. But we're also thinking about high integration, but that's discretion.
First off, thank you very much for all the work done at WPILib. Fabulous tool, and it lets us take novice programmers and get them able to develop robot code very quickly, and that's an amazing example of rising high with all those. However, I find that, especially with our newer coders, it is easy to develop code copy-paste without a true understanding of what's going on. Do you have some advice for how to help new programmers get a deeper understanding of what's going on in the hood in WPILib, particularly for command-based, and training materials as we develop new extensions to help that deeper understanding go?
It's a really good question. I don't know if you guys want to jump in on this, but it's copy-paste programming is a problem across industry, I would say. So this is a much greater problem than just First. I think certainly using some of the introductory tools, where it's tutorial based or building up from scratch, things using like getting XRPs in the hands of teams and saying, hey, follow this, here's coursework on how to build up your robot from scratch. Like, so you aren't copy pasting a whole program in. It's, oh, I've got, I actually do want to learn this, and following that sort of pedagogy, I think can be a good approach. You know, and it's really hard when you're starting with like, oh, I got a swerve base. Like that's a very large step function to start from scratch. But if it's like, oh, here's an XRP with a differential drivetrain, and I can learn how to write commands on that and make it, you know, follow path and run into the wall, right? And not make a dent in the wall because it's a piece of plastic this big, right? That's a way to get teams and students engaged with programming before throwing them at the large problem set, which has much more like, okay, I need to pull something off the shelf because it's just way too big of a chunk. Does that help?
Yes.
I'd say also with your specifically to command-based, we certainly recognize that while it's been adopted by a lot of teams, there's been a steady stream of changes every year almost. And like even going back a couple of years, the way that I wrote a command-based then and now, they're totally different. And even some of our own examples are still kind of older stuff, and that may work perfectly fine. It's just an older style, I guess, of doing that. So I think as we can kind of standardize on different things, standardize on examples, and really show people that there isn't one necessarily correct way, but this is what we're recommending, and recommend that across the board for sound.
All right, we're out of time, but you will be able to find us down in, if you want to talk forward, thank you. You can find us in the Robot Service Center downstairs, behind where's the robot house?